This is Algebra 2, Lesson 9.4, and now we're going to talk about standard deviation. So standard deviation is an error measure, and what it really does is it measures the average distance from the mean of any given data set. And the way that you do it with a crazy awesome formula is you need to take each of your data points and you subtract the mean from that data point. Then you square those differences and add them up. So we're going to use some sigma notation. Then, after you add them all up, you're going to divide by one less than the number of data points. And finally, you are going to take the square root of the whole thing. Now that formula looks crazy scary, but I have all of the steps from the formula laid out in this table here. So you basically just follow along the steps in the table and it's going to do all of that for you. So we have a data table here. It's an experiment where we launched some rubber bands and recorded how far each rubber band went. In feet, we're going to see the average distance from the mean of this data set, also known as the standard deviation. So first thing we have is all the data points in the first column of the table. We need the mean. This X bar symbol means mean. Now we talked about mean, I think the first section of this chapter. To get mean, we're just going to add them all up and then divide by how many numbers we have. 8 numbers. Okay, so let me slide that. We have 12 plus 14 plus 11. Ooh, I'll start over. 12 plus 14 plus 11. 18, 7, 9, and 14. We're going to take that total and divide it by 8. Our mean is 12. The next thing we need is the difference. This column header says take each data point and subtract the mean. So each of these numbers minus the mean. 12 minus 12, 0. 14 minus 12, 2. 11 minus 12, negative 1, negative 1. 6, we're doing 7 minus 12, 9 minus 12, and 14 minus 12. Now the signs on these don't really matter, but I wanted to record them anyway to do it properly. And the reason they don't matter is when we square each of these numbers, a number times itself, we're always going to end up with a positive answer. So 0 times 0, 2 times 2, negative 1 times negative 1 is the same as 1 times 1. We're multiplying each of these values by themselves, all positive answers. The next thing we do is add all of the square values. So we're going to go 0 plus 4 plus 1 plus 1 plus 36 and 25 and 9 and 4. We have a sum of 80. Now we all know how to do a mean. We add all the numbers and divide by how many there are. Next step is called the variance, which is almost the same as the mean. We're going to add all the numbers, which we just did, and then we're going to divide by one less than the number of numbers. That's this sum divided by n minus 1. So I added them all up, and I'm going to divide by 7 because I have 8 numbers. We divide by one less than the number of numbers. So 80 over 7 gives me 11.4. And then our final step, right in the table, it shows to take the square root of that value. And basically, we're undoing all of those squares that we did before we calculated our variance. So square root is the next step there. Square root of 11.4, let's keep some extra numbers just for fun, is 3.38. So on average, our data values are 3.38 from the mean. So why do we care? The standard deviation, like I said, is an error measure, and it's most beneficial when we're comparing data sets. So when we have lots of data sets and we want to see how consistent they are, how far they are from the mean, a low standard deviation means that you are very consistent. You have clusters in your data. All of your data is grouped together. Ooh, this board moves a lot. Very consistent clusters. Whereas if you have a really high standard deviation, that means you have a lot of error in your data. You have very spread out data. And you have lots of gaps in your data. I think that is all we have for the notes on this one. Yep. So good luck on the exercises, and let me know if you have any questions.